Welcome to the second webinar of SciSports. Today we're going to talk to you about BoldGames. But first I want to give you a little bit of background about the company. Thanks for joining us today. We're streamed live to 41 countries over the entire world, so all the continents are represented. Next to me is Maarten.
Yes.
And Maarten is the operator BoldGames, and my name is Giels Brouwer, and I'm the Chief Innovation Officer of SciSports and also one of the founders of the company. What we do with SciSports is that we help professional football clubs by utilizing the data in an efficient way. There's a lot of data out there, but the difficulty is bringing that data into actionable insights. So we build the algorithms that enable the clubs, but also the federations, players, and agents to get additional information from these insights. So rather than providing you with 30 pages of data, we bring to you which players are interesting for you to sign, who are the wingbacks, who are fast in changing position, and who are good in pressing. All those algorithms are built in our offices, which are based in the Netherlands, where we have 3 offices, and we have an office in Germany and in France. First, when we wanted to start a company, we were big fans of football games. So we played a lot of Football Manager, and our Insight platform is basically a representation of Football Manager, but then with real data. After helping the clubs with that, we noticed that the data that we got from other parties was just not accurate enough. We built a virtual reality solution approximately 4 years ago, and in that VR solution, you could walk over the pitch with an Xbox controller, kick against the ball, and actually experience the match from an entirely different point of view. That you could be on the pitch, you could practice like you're on the pitch, and you can choose all the angles you wanted to see. But when we uploaded the data that we got from one of our client clubs, we saw that the ball had no height coordinate. We saw that players were changing position all the time without actually moving that fast on the pitch. And we noticed that if we wanted to build a good VR solution, we should actually start by building a good data generation system. And a couple of years ago, we started with that, and we came up with the name BoldGames. BoldGames is actually named after the godfather of sabermetrics, which is called Bill James. Bill James changed the baseball industry, and BoldGames will change the other sports. And we're going to start with the football industry. How we wanted to change the industry of football is by finally getting accurate 3D data of all the players in the ball. How the data is generated at this moment is basically by manual annotation, by wearables that you put a vest on, or by camera solutions. What the camera solutions usually do is that they differentiate the player from the background, and they use a single view tracking solution. Maarten is going to explain later on how we decided to change that into a multi-view tracking solution. It was during the World Cup when the Netherlands beat the crap out of Spain. Sorry, Spanish guys. But there was an amazing run from Arjen Robben, who outran Sergio Ramos. And during the match, we wanted to actually see the speed of Robben. We wanted to see the speed of the ball and the curve of the ball when Robin van Persie headed the ball, and when he did his astonishing dive. And those aspects is what we wanted to create with BoldGames. What you cannot see nowadays is that you cannot see the speed of the players and the ball in real time. All the data requires manual operators in the stadium, and those people are sitting there clicking who's which player. And our goal was to build the first autonomous 3D tracking solution. And how we got to that point, I'm going to let you know it later. And the system is also patented. Cool thing is that we have a patent on multi-view tracking in a stadium environment, and actually enables us to also share more of the insights that we generate today And if you have any questions today, please let us know. With BullGyms, we also focus especially on the data generation aspect. The rest of the Sai Sports company is focusing on getting insights from the data, but BullGyms mainly and only focuses on generating the data straight from video footage. Right now, we work on our own camera solution, which is installed in one Premier League stadium, one Dutch Eredivisie stadium, and a research lab at the University of Twente. And for that, we are always looking for partners. Partners that want to help us by enriching the data, that want to help us with research, that want to enroll the most innovative tracking solution in entire leagues, or just at their own club. If you're interested in that, please let us know so we can get in touch with you, and we are looking forward to create the future of sports together. Because the ultimate goal is, after rebuilding Football Manager, we are now rebuilding the game of FIFA. Actually, we play a lot of FIFA here at the office. Matt is not so really good, and I'm not so good either, but some of the guys are actually one of the best. And what we see there is, when you're playing on the radar that's in the bottom of the screen. And when you watch your real match, you also want to see the radar, so you can see the movement of the players that don't have the ball at this moment. And to build the most advanced algorithms to actually unravel the entire football match, therefore you need additional data. And with BullGyms, we are able to generate entirely new insights, and we're going to actually show you some of the footage of a match of Heracles Almelo against Ajax that was played a couple of weeks ago in the Heracles Stadium. I think I'm going to give the word to Maarten.
Thanks. Yeah.
If you have any questions, please feel free. If you have any ideas, please feel free. But first, Maarten, the floor is yours.
Yeah, thank you, Giels. And nice that I can share the stage with you and explain what BullGyms is all about. To start with, you can share your questions in the sidebar of your webinar app or website. So please feel free to do so. We'll come back to the questions at the end of the webinar. So stay tuned for that if you want to have your answers. To start with myself, my name is Maarten Koster. I'm delivery manager of BullGyms, as introduced by Giels. And I just joined Sai Sports actually a little over 1 year ago, after 10 years of working in consulting industry. I really like the exciting ride that I've made the last year, and I think it's also, quite a lot of changes and quite a lot of development has been going on the BullGyms system and product. And that's actually also the reason why we're here in this webinar today. We're, let's say, in the validation stage of our product. So it's coming out of the lab. We're capable of demonstrating, generating real-time data within a stadium live during a match. And well, we really want to show that and get back or connect to you if that's also relevant to you. So this is an open invitation actually for everyone.
Yeah, so if you want to see a match of the Heracles Almelo in the Heracles Almelo Stadium, where we can demonstrate the real-time live tracking, and then reach out, because we have our skybox in that stadium, where you can actually see the match and see the data generated in real time from the 14 cameras, and see the insights.
True. So what I'm going to walk you through today is, the challenges we overcame last year. So how we got to the system and what we needed to do to make it all happen. And I'm going to show you where we currently stand, and to share some ideas we have on the next steps to take to get BullGyms to the market. Let's start with that now. So yeah, that's coming up now. Thanks. And we go to this one, actually already explained by Giels a little bit. One step back. So what is BullGyms about, and why did we rebrand it or brand it differently than Sai Sports? Sai Sports is all about creating insights in the football industry, actually. So using metrics, models, and insights and real advices, so actionable stuff that really helps clubs or agents or players in, let's say, developing themselves or strengthening their teams, for instance, in the recruitment process. BullGyms is actually generating the raw data that can be used in those metrics, models, and insights. But it's not really necessary. So Sai Sports is or will be one of the customers of BullGyms, but we can also reach out to different let's say, customers with our BallGame system. And the other way around is also true. So SciSports is not only using BallGame's data to create or gain their insights, it's also, let's say, using other kinds of data sources to get to that. Topic for today will solely be focused on this bit underneath, so the BallGame system. To start with the challenge, so Giels already mentioned that he had his vision and his dream actually to really experience a game in a VR kind of way. Well, what's required for that? That's generating real-time 3D data, which means that you need multiple data points per player, as well as the ball, real time, so multiple times per second, and then when the match is actually played at that moment. Well, that's quite a challenging thing, but that's the only way that that can really enable the things that we want to reach with this, and that's let's say creating value for clubs to even help them further and getting insights in the performance of their teams or the tactical work that they're doing. We also think that it can help for the game. So eventually 3D data will help in creating, for instance, a data assisted referee. So we're not there yet, but we believe that we can create offside detection based on tracking data that we generate. Well, the third and the fourth are a little bit related to each other. It's for media and for fans. So for media, of course, well, for instance, displaying a radar plot of the match during the live match on television screens. And for fans, well, you can think of multiple, let's say, next generation statistics that can be displayed in apps or in, well, whatever news channel they follow based on BallGame's tracking data. All in all, very exciting opportunities, I would say, and that's also what made me excited and made me willing to join SciSports as a company, well, to really bring the next generation and the future to football. But yeah, question is then, how are we going to get there? And we decided to look into different industries as well, and we took one thing as an example, and that's the autonomous driving that's really happening at the moment, especially in Silicon Valley, I would say. And well, there are quite some parallels here, because what autonomous driving tries to solve is actually also detecting whatever cars or pedestrians are around. Where is the road? What are the signs, or what are the rules that are applied here? And that's something you need to find, detect, but also need to analyze and eventually even make decisions based on that. So am I going to speed up or am I going to brake? Am I going to steer or am I going to go straight away? Well, these are quite complex problems and they don't always go right. So even in, let's say, a large industry where many companies within Silicon Valley, the Ubers, the Googles of these worlds are working on, even there you can see that accidents might even happen. And well, that's, let's say, a bit of the challenges that we are also facing during the development of BallGame. To get back to where we started. So we wanted at least to take the same approach as these guys in the autonomous driving industry are doing. I think, well, we think that's the actual only way in solving this complex problem of generating real-time 3D data. And that's how it brought us to the deep learning way of working as well. And why is that? Yeah, why are we sitting here now? That's actually probably interesting. Well, this deep learning is really coming up, and that has to do with a couple of market developments that have been going on. I'm not diving in too much detail on deep learning, but it's all about, let's say, learning computers the same stuff that humans can also do by giving them a lot of examples of what they have, a lot of examples actually. So if you show a computer a lot of balls, pictures of balls, then eventually he will, if you just show him a picture and say, hey, is there a ball on there? Then he can tell you, yes, I see a ball over there and it's in this area. Well, that's actually what deep learning is all about. And that is enabled by large amounts of data that we are encountering, we're having actually at the moment from football matches, but well, in general, as the internet is growing, I would say. The other thing is quite a lot of GPU capacity is added. So computers are becoming faster and are capable of making these complex calculations way better and better. And well, what is relevant for us as well is that these algorithms are becoming, let's say, more advanced, but also that, well, the development in cloud engineering. I will come back to that later, but that's really enabling us to create our solution based on the deep learning approach. Well, what do we then need to do? Because what we actually want to achieve is generating real-time 3D data of a football match. Well, what you then need, of course, is footage from a match. Well, to start with, this is actually the main components of what we have built the last couple of months, and even, well, a little over a year, I would say. But the first thing you need is the left side is footage from those matches. So we need a way to get, well, the video footage in. I will come back to the details later on, but that's already a complex problem. Then the second is we need to process these large amount of video data and to create, let's say, insights, or to let the computer learn, or tell us what he sees in there. So that's the other thing that's relevant here. Then these are the deep learning algorithms actually that do so. And then there are some additional algorithms to do the player and ball tracking. And then everything has to be deployed real time to create those direct insights to end customers. Well, creating this faces quite some challenges, and that's what I want to go through with you. We've encountered 6 challenges that we've solved last year, I would say, and I want to show you why this is this complex and, well, what helped us out there. To start with, having match footage. So Giels also explained how many other parties are doing is either, well, using GPS kind of trackers, or using, for instance, a panoramic view and do single view tracking. But that, well, won't really solve the 3D problem, because to generate 3D data, you need the footage from different angles to reproduce where a person or a ball is actually located. Then you can also go for TV footage, but you have to deal with moving cameras, and you don't really know whether the entire pitch is covered. Well, that eventually made us decide to create our own camera platform, where we place 14 cameras around the pitch, and where we generate 4K videos out of all of these 14 cameras. And that's actually the baseline for our BallGames product at the moment. That doesn't really mean that we are dependent on these cameras only. We see a development that many cameras are installed in football stadiums at the moment, and we're, well, let's say, looking for all kinds of ways to at least get our video footage that we need to process the data with. And as Giels also mentioned, we have installed this in 3 sites. So at the Heracles Stadium in the Dutch Eredivisie Stadium, it is in Almelo, at a Premier League club in London, and in a research lab at the University of Twente, and that's the actual picture you see over there. It's the installation at that university. But all in all, we have now 3 sites where we can actually run our platform on. We have the footage from those sites, and what is it? Other advantage of having these own sites is creating our own match footage, and that is also helping in the deep learning approach, of course, because we generate data. We also use that video data to train our own models again, and to make them, let's say, robust and work with all different kind of circumstances that they can encounter. I will get back to that later in the other challenges we face. So we've solved this first one. We've got footage, but then the question is, we need to process that footage. Well, you can think of having local solutions. That's what the autonomous cars, for instance, do. They have the processing in the car, and the car decides whatever to do with that. We do some processing at the cameras, at least to make sure that the video footage is made smaller, so that we can actually process it and send it throughout the cloud. However, we cannot do all the processing there, and it would also, at the current situation, make us really dependent on those cameras, and it's going to be a, let's say, a very capital intensive solution. And what we see is those developments in clouds. We only need the GPU and CPU capacity during matches. Well, that's only 2 hours in the, let's say, 1 or 2 weeks whenever a match is played. So it's better to spin up capacity at the moment you need it in the cloud instead of having all the fixed infrastructure everywhere. So that's why we decided to go for a network and cloud infrastructure. So we make sure that all the camera feeds are going via a stadium infra to a central stadium point where we send it via a dedicated SD-WAN network to our own processing cloud. And that's where, let's say, the actual processing takes place. And to give you an idea, the 14 4K cameras generate around 3 terabytes of video data every match. So that's huge amounts of data that we really are processing there. And that's, well, that comes with some challenges. But we've solved this one as well. So that's the second challenge. Then the third challenge. So if we have the video data in the cloud, then we need to detect whatever is on the pitch. And that's actually the next challenge. So how are we going to identify players and balls on the field? Because that's where we're focusing on. We want to generate data from those players and balls. And that's also the first step in our pipeline, where the deep learning module is really based on, let's say, all the training data that we gave him, able to actually, well, detect players and the ball. So you see that all the persons on the field are, let's say, labeled as player. If you can see that, it's a little bit hard to see probably. And that the ball is classified as a ball. So now we know from 14 angles what is a person and what is a ball. And that's actually the problem that this detection engine is solving, and it's really good at it at the moment, I would say. And to also give you some idea of why is it so good, there are like hundreds of thousands of pictures of players and balls in our learning database. Well, that helped that detection engine in actually recognizing what is what. Well, when you have classified or detected the players, then you're facing the next challenge, because you're not actually tracking it. So you need to do that frame over frame, and you need to combine all those 14 different angles to actually generate the X, Y, Z positions, for instance. We first do that for the ball, and that's also a challenge that we've encountered and solved as well. So what you see here, at least in the small circle, is that we follow the ball, but that we can, let's say, find the XY coordinate, so the ground plane thing, as well as the Z coordinate, the Z coordinate, sorry, and that's the arrow in the air. And you can only actually calculate if you have footage from different angles. Otherwise, well, it could also, from this picture only, for instance, you would probably say that the ball is out of the pitch, but it is actually on the pitch, but then in the air. So challenge solved as well. Then the fifth challenge, and there it becomes more complex, I would say. We've seen that detector was able to classify, to detect different persons on the field, but then the next challenge is actually to classify those players and to say, hey, which player is which? And what you see here is actually the classifications from one camera angle, where it classifies players from, in this case, the Heracles Ajax match of last February, in a couple of buckets. So you see that a keeper is classified differently, a player from Ajax is classified differently, a player from Heracles, a referee, and the one you won't see is the keeper from Ajax, but he's also classified differently. So that's step one. And then step two is, of course, making individuals. So there are 10 players from each team. And we do that based on numbers as well as some other features that are, let's say, within the deep learning module. But you can think of haircuts and shoe colors and stuff like that. That's also incorporated in, let's say, making those players individual. And what you see from this angle, for instance, is that player Ajax at least is recognized as player number 31. That's the one you see from the back. So the angles that sees the player from the back also helps in classifying what player it actually is. And then there's the last step. So if you know who is who per frame, then you need to combine those 14 frames from 14 camera angles, and well, make actual tracks out of it. And that's the last challenge we faced. And that's also the challenge we've ticked the box for, and that's the 2D player tracking. So that's actually the current solution we're having. So the dream or the end goal is still to create 3D data, but we decided to start with, let's say, a little easier problem, which is making 2D player data first, which means that we know the XY position of, let's say, the body mass of every player. And that enables us, for instance, to create the radar plot that you see on the left side. Oh, of course, and the ball is still in 3D, as mentioned earlier. And we're working on ideas on how we're going to enrich this 2D data to 3D data. So we can think of a couple of steps to get to that skeleton data. So having, let's say, a data point for every ankle, knee, elbow, shoulder from every player. But in between, there might be steps that are also useful. So for instance, knowing the body orientation or the face direction, as this might still be relevant in terms of football. So many football analytics people are currently, let's say, looking for face direction information, as well. Good players deemed to be having an oversight over the field, which means that they really are looking around continuously, and you can actually measure that with those kind of data points. Well, so all in all, 6 challenges. Ticked all those 6 boxes the last couple of months. So now we really have a solution which is non-invasive, so not using any sensors or whatever that the players need to wear. It's a scalable cloud, so currently we are installed in those 3 stadiums, but it's relatively easy to scale up for, let's say, more sites, as the modules are running in the cloud. The only thing we need is video footage then, of course. It is accurate. We believe it's more accurate than any other tracker, and it's real time, so it's live generated during the match even. And to prove that, we want to show you some videos of what we've created. What we see here is actually the same as we've just seen in the slides. And it's a look in the engine of the BallGym system, actually. So this is video footage taken from one of the 14 cams, and we overlaid the tracking data generated over the pitch. So you actually see the players moving, and that we are tracking those players. Well, we can also display a radar plot in here. As you can see, there you can also see the 14 camera angles, and we can switch those angles by just clicking on them and create footage from another camera. We can zoom and, well, go through those different views. And actually, this is a tool that we created to do debugging, so to test and improve our system, so to see how it's actually reacting. But it's also, we found that it's also insightful to show to potential customers or potential partners like you, because it actually shows how data is generated and what it looks like. So in a couple of minutes or seconds, I would say, we're gonna watch the goal of Heracles against Ajax. So there was the match played last February, 9 February, where Heracles won actually from Ajax with 1-0. So they outperformed Real Madrid there, I would say. What is also interesting to see now is getting a little bit more of insight in how the entire system is working. So we see the bar underneath now, and that's actually displaying all the data that's going through. So you see 5 colored bars actually. The upper one is, let's say, the first challenge that we've solved. So all the video data that's coming in. The second bar is actually where all the detections are coming in. The third bar is then where we classify those, so that we actually classify the player data. Oh, we see the goal of Heracles at this moment. And then the 4th and the 5th bar are the respective the player and the ball tracks. That was it. But it's really insightful to see how we actually generate the data based on video. Then I think most of you might have the question, okay, then we have data, we have XYZ data. What's next? Well, as Giels also mentioned, so BallGames is currently not really working on creating insights based on that, but actually just creating the raw data. That's the main focus for now, and making that even more accurate and more real time, I would say. But we also created a dashboard that you see now to actually show a little bit of what is possible with the data. So you see the same kind of radar plot on the left, and you can see the possession during that match in the middle, and a heat map on the right. And this is, let's say, continuously updated during the match, even during live matches. So that's, you see the same goal of Heracles here again, just scored, and they're starting to celebrate their goal now. A couple of other things that we've also created here is the number of sprints of the distance that's covered per player and per team, the distance covered. So these are all, let's say, metrics that you can calculate based on tracking data, and that might be relevant, for instance, for coaches or performance analysts. We can do that on team level, as you've just seen, but we can also go to individuals, players. For instance, go to Tadic at this moment. There's an individual, let's say, barcode of his match, so where the intensity was. You see a heat map of where he's actually run. You see all the high intensity runs that he's done during that match. And on the right side, you can also see what direction those sprints and runs had. And you can also see that his most intense runs were, let's say, running to the front. Well, that's a little bit of insight in what you can do with the data, but actually that's the point where we are currently at. So determining the next steps. One of the opportunities is evaluating every action, which can be relevant for clubs or performance coaches, but probably even for media and fans. So to determine the fastest sprint of the players, or the fastest shot on goal. Those are, let's say, individual things that you can measure and actually display in apps or on television screens. And the other direction we think is possible is creating team insights, or even the data-assisted referee that we've mentioned earlier. So, for instance, here what you can measure is the distance between the different, for instance, the defense and the offense line of a team, but also the distance, for instance, between two direct opponents. And you can continuously measure that. And for a coach, that can be relevant because if he gives an assignment, okay, you're going to stay close to Messi. Well, how far were you away from him during the match, and where were you actually performing well? But what were also the moments that you were, let's say, made him run around too free, so to say. And I think, well, one of the other things is, of course, the data-assisted referee. So if you can conclude stuff on where players are standing, where the ball is, then you can also conclude on offside, for instance. Quite a lot of information, quite fast probably. But yeah, this is what I wanted to share with you all. I give the word back to Giels to continue on, let's say, what the next steps for us will be.
Yeah, so basically, thanks, Maarten. If you have any more questions, more in-depth technical questions, please leave them in the comment or in the question tab. We will answer as many questions as the time allows us. So we're gonna go through it in the end. But first, as you can see, we developed a lot of different aspects. All these aspects are not only generated by ourselves, as we are a team. The entire company consists of slightly over 50 employees, of which half is working on the BallGames solution. But we do a lot of them with our partners, and I think our partners are always one of the most crucial elements of our company. And I especially want to emphasize the R&D department, R&D collaboration we have with SAS, because what we are basically doing together is that we are creating entirely new applications of deep learning in the sports industry. Together with their R&D department in their headquarters in Cary, we find new edges to make sure that we can generate the data faster, but also provide insights to the coaches when they go back to the dressing room. So when they head in, they will have the first reports from their matches, and they can actually see how well they are performing during the match. For the event data, we make a lot of use from Wisecout. They manually annotate the data, and we were also able to train our models based on their video footage. Our solution that we can stream to the cloud is all hosted on the Google Cloud platform. We can spin up 42 virtual machines at the same time to do part of the processing over there. And to make sure that we can create pre-processed camera feeds, we managed to use the NVIDIA GPU that we install on the camera, and where we can make sure that we can get the total video storage, or the total video files that we have to process, back from 3 terabytes to 400 gigabytes during a match. And last but not least, we work together with many universities, but for BoldGames, we have the campus at the University of Twente, and we have a partnership where they are hosting the research with us together, and they also enabled us with the opportunity to make sure that we can stream and share the data with all external parties. Of course, we can only share the data of the students that allow us to share that data. But because these are not professional players, and they are welcoming us to share the data, we are opening a research and field lab. We opened it 2 weeks ago, and we open up our open data science pitch for the entire world, where everyone can join us in the goal to enrich the game of football. Enriching the game of football and making sure that we can bring the FIFA experience of the game into a real match is always the goal. We want to make sure that we can create an AI of individual players, that we can predict better what we are doing, what they will do. And in the end, we are using the Tesla approach. So we're starting off with 14 cameras to build the elite system, but in the end, a feed agnostic solution is our ultimate goal. In 5 years, it should be able to create the BoldGames system with iPhone 12 cameras, where you install them around the pitch, create an internal network, and generate the data of your own. And for that, we need our research partners, of course. We want to be the first that can do real-time skeleton tracking. And we need a lot of people that can join the research with us together to make sure that we are the first, to make sure that we can stream that in real time. So the VR dream, the FIFA experience that you get from the match, can be streamed to everyone. And if you want to join us, if you are a federation club, if you work in visualization or VR, if you think you can build the next coaching app to make sure that all the coaches that work with us can actually get the new information and entirely enriched information to the fans, we are always welcome to join you in a joint partnership. For fan engagement, if you want to build a new over-the-top television OTT solution, get in touch with us, because we provide the API, the data, and everyone else is able to work with the data. So the BoldGames generated data is able to get streamed to every opportunity that you are looking for. We are always looking for new ways to ingest videos. So if you have a lot of video footage, or if you are working with new cameras or an entirely new solution in that aspect, please reach out to us. And as I mentioned before, research partners, or even if you are working on computer vision or deep learning for yourself, and you want to do research on football because you think football is epic, just like us, let us know if you're interested, and you can do it via this webinar, or send a message to one of us. That brings us to the end, but of course we still have time for questions. We saw a lot of questions coming in. We try to answer as many as we can, but therefore please feel free to continue sending in your questions, and our colleagues are creating the questionnaire list for us. So let's get to the questions.
Question 1 is it possible to use BallJames to analyze broadcast footage from 4K or 1080p recording cameras, or does it have to be specific cameras produced by you? Well, at the moment, it is our system is equipped to do it by specific cameras produced by us. However, we're working on, as Giels mentioned, on a camera agnostic system. So I would say not yet, but that's how we envision our future. We're working towards ingesting different kind of video feeds. That's actually the answer.
Yeah, and right now it can also be used. The 4K footage that we generated is also used to do the video analysis of the players and the teams that are already using it. We have a BallJames solution, see the footage from 14 angles to make sure you have everything covered. So either you want to see a goal again, or you want to bring the video footage to the players, you can always see the videos from there.
Next question is, are you capturing just physical data with BallJames or performance data as well? Well, good question. I think what we actually do is capturing raw data. And what, for instance, what you've seen in that performance dashboard is one of the, let's say, possible use cases of that tracking data, which is generating physical data. But you can generate, let's say, all kinds of matrices or models on top of tracking data. So I won't say it's only limited to physical data. I would say there are quite a lot of opportunities. However, we are currently not creating those. Well, SciSports is using a bit for their own models, but the raw output of BallJames is actually only tracking data, which is probably haven't described that so good, but what it actually is every 1/25th second, so every 0.04 seconds, you receive all the XY coordinates of all the players and referees and the XYZ coordinates of the ball. And that during 90 minutes of the match.
Are you interested in research collaboration with individuals? If not, are you open to remote job positions? Of course, we are open for research collaborations with individuals. So please reach out to us if you have a good idea, or if you are open to work with one of our research topics, because we know we have plenty of work to do for now and in the future. Remote job positions, well, I think over the last year we flew in almost 20 of our employees from distinct locations from all over the world. We do believe that it's important for us to keep the core competences and the core employees at the same place. So the BallJames office is mainly located in Enschede. And with that, we have all the team together working on the same dream. And for me, it's important that you can look each other in the eye sometimes. For sales or for a partnership or for joint research, you can always do it via remote locations. But I think if you want to work at BallJames or SciSports, we prefer you to work in one of our offices in the Netherlands.
Kaan Kosbeck is asking, I'm doing my master data science thesis about predicting defensive pressure based on X and Y coordinates during a football match. I was curious about if the system of BallJames also predicts these kinds of features. I think the answer is comparable to what we've discussed before. So at the moment, BallJames is actually only outputting tracking data, which is this X, Y, and for the ball Z coordinates. But we are not predicting anything yet, I would say. But yeah, looking for partners to help us to create those insights as well.
Agreed. So it's definitely one of the goals that we are aiming for. So doing the micro eventing so we can generate the events based from the camera feed. But right now we're focusing on the XY coordinates. Can ball James help coaches to make decisions during a match? Yeah, definitely. You can see the decrease in acceleration. That's one of the indications of a player getting tired. When a new player comes in and you see that the right winger is way faster than the back, the coach can make the decision to substitute the player that's actually having a higher acceleration on the first meters or is better in the high intensity runs. We won't make the decisions. Ball James won't make decisions. The coach will always make the decisions, or his analyst team. But we can supply the information that can help the coaches to make the better decisions during the match.
I see the camera feed is coming back. Probably that applies to all of you. Welcome again, guys. Question here is, are you guys using or can you video games like FIFA for aided training or simulations of the Ball James algorithm? Yeah, actually, we well, that's a little bit of let's state it. Let's say open. We use all the ways that we can to train our models, and it's up to the creativity of the audience, whatever we use, I would say.
So we can be flexible, and if you have good ideas that we can increase our training set, we are always looking for ways to increase our training set.
Exactly.
What's the standpoint of FIFA UEFA on your technology? Well, the FIFA recently announced their EPTS data protocol. The Ball James solution provides us with the data that's applicable for EPTS solutions. So the data comes in a way that the FIFA approves our API way, the way we build our API. I cannot speak in terms of the FIFA and UEFA regarding how they feel of it, but they we've been to Switzerland.
Feels this one is for you.
Can Ball James help by determining if a ball is out of line or not? For example, the normal cameras at the Real Madrid Ajax couldn't determine. Really good question. I think one of the best applications of Ball James, because we can get more accurate, is that that can help with the offside detection during the match. And next to that, because we have the optimal coverage during the match, what you see nowadays with the VAR is that sometimes it lacks the accurate position of the cameras to determine for a small stadium if the ball is in or out. Even the most complex solutions will always be difficult. So in case of the Mazraoui, was the ball in or out, determining that, I cannot say it for sure, but we do aim at the most difficult situations. Unfortunately, we don't have it installed in the Santiago Bernabeu, but there would be a nice stadium to check it anyway.
And probably to nuance it a bit, it is fairly difficult. So you probably asked the guys from Hawkeye how difficult it is to actually determine whether it's a goal or not. We've seen that at the Juventus Atletico Madrid game. It is very hard to see, and even afterwards you have debates on Twitter, for instance, whether that ball has or hasn't passed the line. Well, it was at least a goal. Oh, this one is yours as well. Are the slides or video going to be available afterwards? I would say yes.
Yes.
So we'll share that later on. Yeah, you will get a notification of that, I assume. At how many frames per second are the cameras recording, and are all cameras synchronized so that frames are at identical times? Well, yeah, that's actually yeah, one of the, let's say, secrets from Ball James, but good question. The cameras are currently recording at 25 FPS, but are capable of 50 FPS. However, that would double the amount of data that we would need to process, and at the moment, the 25 is sufficient for us. At least for the current applications. So we're working with 25, and the cameras are indeed synchronized to make sure that you're actually capturing the For instance, if the ball is in the air, you're capturing that from different angles. So you need to make sure that this frame is shot at the exact same time to determine the exact location of that ball, for instance. So yes.
Yeah, that was quite an effort at the beginning. It took us several ways of applying the frame synchronized frame generation, so you can do it within just to get them frame synchronous.
Yeah.
Because if they're out of synchronicity, then the data would be less accurate.
Yeah.
Because when a ball travels with 100 kilometers an hour, with 25 frames a second, and then the camera's angles are, or this timestamps are off. So we actually built our in-house timestamp solution to make sure that all the cameras are time synced for all frames.
How did you classify the images that were used for training the algorithm to identify players and ball? Well, that's a pretty technical question. I'd rather ask that the guys from the research and development department, I would say, and probably they won't even disclose this either, as it's probably part of something, let's say, underneath of the engine hood. So we might get back to it later, or we might not. I can't tell at the moment. Sorry.
Yeah, but we did have a large group of people working with us.
Yeah.
Generating the part of the labels that we generated.
True. Yeah. How much MP is the camera? Good question as well. I don't know by head. It's quite a lot. I think 8 or something, or 12. I don't know. 4K resolution. Yeah. How long is the data storage? I don't exactly know what is meant by that.
I think it's according to GDPR. There's consent by the players.
Yeah.
Well, what's usually determined by the entire league is that the players agree with the clubs that their data can be shared. Of course, we have to apply to all the GDPR laws. We also did the research on that, and we are aiming on either league deals or club deals. And then we make sure that the club is responsible for providing us with the relevant information to get approved by GDPR laws. So we don't store the necessary information, unnecessary information, without any need.
Yeah. How usable is Ball James when you have only video footage from TV? Are you still able to do 2D play tracking and 2D ball movement? What do you lose when you don't have the 14 cameras? Well, currently we are dependent on the 14 cameras we have ourselves. But yeah, we're, let's say, working on making this camera agnostic. But I can't tell at the moment what the difference is going to be actually. We've seen competitors doing it, and what you normally see actually is that it's fairly difficult to get to the actual positional accuracy that we can provide, especially for parts in the far field and when the ball is, for instance, at height. So when it's on the ground plane, it's okay, but then when it travels through the air, then it becomes fairly difficult. Yeah. And then the next question, will the positional data be connected to event data? And if yes, how will it be done? That's one of the challenges that I haven't mentioned yet, but it is certainly it is one. We want to synchronize our feed with event data feeds, and ultimately even create our own event data feeds based on, let's say, the deep learning algorithms. We're not that far yet, as you've just seen. But the answer is yes, but we are not there yet, the honest answer.
Can you agree with partner clubs to use tracking on the players, which I understand is data technology already existing to help further the positioning of players / ball? What I meant with the previous question is that combining with positional data, then more accurate detecting of specific players can be achieved. Is that an option? Yes, definitely. I think what you mean is if we can build a hybrid solution where the players can wear wearables and we do the tracking with the cameras, And we are testing that with 2 providers of wearable solutions, where we do the actually, because we don't have to classify the players a lot better, but we know the region where the players are, and we can increase the quality of the tracking, or decrease the computing power we need. That's a better way of saying it. And altogether, we can focus more on generating the 3D data out of the players, so focusing on new aspects like pose or limb detection. So we are looking into that situation. Also, always looking for interesting partners in that aspect as well, that can do accurate tracking, as we believe that there could be clubs that are in need of such a solution. Because wearables can't help you with tracking the ball, or tracking the opponent team, but they can help you with measuring your heartbeat, for instance. Okay, we just got an angry guy.
Yeah, that we're going to stick to 3 minutes, so I guess we cannot answer all the questions. I think we might come back to them later. So we can still answer a couple of them. To start with the following: how do you get ground truth of your algorithms? Are all the matches manually annotated? Well, I cannot say too much about that, because that's again, that's part of the engine. Yeah, let's state it this way: we are, like every party probably is, creative in getting our ground truth data. That's probably the best answer.
Yeah, and we're really focusing on validating the system right now. So we already discussed that we are working together with multiple wearable solutions, which can help us with that. The University of Twente will help us by validating the solution, but we're always open for more and more sophisticated tracking validations.
What's your real-time latency? Good question. I was expecting that one earlier, actually. At the moment, it's somewhere between 1 and 2 minutes, and we know, so we've built in some, let's say, security stuff there. We know that we can bring that back to, let's say, within 30 seconds or even faster. However, that would also require additional computational power, and we can put it in, but at the moment that doesn't really pay back. So at the moment, once again, if you would go to the Heracles Stadium and watch your match live, then you'll see the data flowing in between 1 and 2 minutes after the actual events on the pitch happened.
I think this will be the last question.
Yeah. Are you doing anything with field of vision? Which direction the players are looking? Probably I've explained that already. So we do not do that yet, but it's one of the, let's say, next step research question to go to more 3D data, so to say, or 2.5D, if you will. But yeah, that's so the answer is currently not. In the future, I guess we will.
Yeah, it's not in the development pipeline, but we did the prototyping and proof of concept. We built it already, where you can see the body orientation and the way players are looking. As one of our clients is really interested in that space, and because if you say if you can see in which direction a player is looking and how often he's changing his vision, they can actually see how well he's performing in certain situations. But that's it for now. I hope you enjoyed it. So thanks for your time, and thanks again, Maarten, and I hope you had a good trip. Thank you.